So, how do you securely host multiple local web apps without completely exposing your internal network to the wild internet? I mean, if you've ever tried to host your own internal tools, you know exactly what I'm talking about here. You're usually stuck choosing between two absolutely terrible options. Option one, you pay those exorbitant recurring cloud hosting costs every single month just to keep your tools off your local network. Or option two, you face the security nightmare of opening up ports on your home or office router, essentially painting a massive target on your back for every malicious bot out there. But what if there was a third way?
Well, today we're diving into modern zero-trust architecture. It's a total game changer that completely bypasses those traditional headaches. And by going this route, we actually unlock 4 huge benefits. First up, zero hosting costs. Because your existing web server doesn't have to run these applications, your local PC does the heavy lifting. Second, absolutely no public IP address is required. Third, and honestly this is absolutely crucial for your security, there is zero router port forwarding involved. Nothing is exposed directly. And finally, you get automatic startup, meaning your services just run quietly in the background without you having to lift a finger.
Welcome to The Explainer. Today we're going to demystify this entire technical process step by step. We're looking at a complete guide for hosting multiple local Python apps using Cloudflare Tunnels and NSSM. We're going to see exactly how this works under the hood so you can execute it perfectly on your own hardware. Here is our roadmap for today. We'll be covering secure local hosting architecture, prepping your local apps, automating with Windows services, building the Cloudflare Tunnel, routing your subdomains, and finally, verification and troubleshooting. All right, let's jump right in.
Section 1. Secure Local Hosting Architecture. Rethinking External Access. So everything starts out on the public internet. Imagine you, or maybe someone on your team, opens up a standard web browser at a local coffee shop. You type in the URL of your internal app. Now, that browser is trying to securely access your internal application, which is sitting safely behind your firewall. In a traditional, old-school setup, this request would go straight to your router, which, as we know, is incredibly risky. But here is where the zero-trust approach completely flips the script. Instead of hitting your home or office router directly, that browser request securely hits the Cloudflare Edge network first. Cloudflare acts like a giant shield here. It absorbs the initial traffic, handles the SSL certificates, and ensures the request is actually valid before it gets anywhere near your physical hardware. And this brilliantly illustrates our secret tunnel concept. Instead of your router just sitting there waiting for an incoming connection, your local PC actually reaches out to Cloudflare from the inside. It creates a persistent, encrypted, outbound connection. And because the traffic originates from inside your network, going out, your firewall just allows it naturally. This means absolutely no open firewall ports are required. Your network remains completely invisible from the outside.
Section 2. Prepping your local apps. Avoiding port conflicts.
Okay, so the crucial point here is that every single application running on the exact same PC must be assigned a unique local port. You literally can't have two apps trying to use the same door. For instance, you might run an internal ERP system on port 8501 and a completely separate CRM on port 8502. The master guide advises testing this locally first, so you should be able to open up your local browser, type in localhost 8501, see your ERP, and then type in localhost 8502 and see your CRM. That proves they both work independently without stepping on each other's toes.
Section 3. Automating with Windows services. Surviving system reboots.
Picture this. A Windows update forces a restart at 2 a.m. Your apps need to come back online automatically, right? You don't want someone needing to physically log into the machine every time. To achieve this kind of unattended reliability, we use an incredible utility called NSSM, which actually stands for the Non-Sucking Service Manager. Now, by default, running a Python script means keeping a command prompt window open on your desktop. If you close it, the app dies. NSSM solves this by taking your standard Python scripts and wrapping them up as robust background Windows services. This means they start up with the operating system itself.
The execution is actually super straightforward. Opening up an administrator command prompt, you simply run nssm install app1_erp. This lets you configure your script path and run arguments. Once that's saved, typing nssm start app1_erp instantly turns your app into a background service.
Then you just repeat this exact same execution for your second application. Run nsm install app2crm. Configure the path and your new port, which is 8502, and then start the service. Boom! You now have two distinct Python tools running quietly, efficiently, and automatically in the background of your Windows machine, completely detached from any user's desktop session.
Section 4. Building the Cloudflare. Creating the secure link.
Deploying the tunnel itself is a highly structured 5-step execution straight from the Cloudflare dashboard. First up, download the Windows AMD64 Cloudflare executable. Second, log into your Cloudflare Zero Trust dashboard and navigate to networking, then tunnels. Third, click to create a new tunnel and name it something you'll easily recognize, like My Local Server. Fourth, select Windows as your operating system environment. And fifth, Cloudflare will magically generate a single, custom installation command. You literally just copy that command, run it in your administrator command prompt, and that's it. The tunnel is established.
Now, there is a vital security speed bump here that we absolutely have to talk about. The command Cloudflare gives you contains a very long, unique string of text called a tunnel token. You must treat this token exactly like a highly sensitive password. It is literally the master key to bypass your firewall and enter your local network. Never publish it in screenshots, do not commit it to Git repositories, leave it out of public documentation, and for sure don't paste it in a Slack chat. Protect it fiercely. If it ever does leak, you have to immediately go to Cloudflare, revoke it, and generate a new one.
Section 5. Routing your subdomains. Directing internet traffic.
Inside the Cloudflare dashboard, under your newly created tunnel, you'll head over to Public Host Names. Here, you map each specific public URL directly to its corresponding unique local port. So, you map app1.yourdomain.com to HTTP localhost 8501. Then, you add a second route map in app2.yourdomain.com to HTTP localhost 8502. You are basically teaching Cloudflare exactly which door to knock on inside your PC based on the URL the user typed in. It's one single tunnel gracefully handling multiple different applications.
Before we finish the routing setup, though, there's a critical production tip to keep in mind. Simply publishing a host name like erp.yourdomain.com does not mean it's private. Anyone who guesses that URL can hit your application's login screen. So, for truly sensitive internal systems, you must layer on a Cloudflare Access policy. This forces users to authenticate, like logging in with their Google or Microsoft account at the Cloudflare edge before they're even allowed to see your application's front door. It is an absolutely essential security layer.
Section 6. Verification and Troubleshooting. Testing your deployment stack.
Look, things don't always go perfectly on the first try, and knowing how to debug is crucial. If anything goes wrong, we can use this diagnostic matrix to quickly isolate the issue. If localhost 8051 doesn't even open on the PC itself, well, your problem is at the application layer, so check your Python code or your NSSM setup. If localhost works but the public URL fails, the issue's at the network layer. Check if your tunnel is actually connected or if your DNS records are right. If the app works perfectly when you're logged in, but fails after a restart, you've got a permissions or startup setting issue within Windows services. And finally, just ensure you haven't accidentally installed the Cloudflare service twice, because duplicates will definitely cause conflicts.
Once you've debugged, run through this final deployment checklist. Make sure you check off every single item. Apps work locally. Unique ports are set. NSSM services are running. Cloudflare is installed once. Host names map correctly. DNS is solid. Access is enabled. Credentials are safe. But listen, the absolute most important test here is the reboot test. Literally, restart your PC, do not log into Windows, and try to access your public URL from your phone. If it loads, you've done it. You have achieved a truly resilient, fully automated deployment.
This setup fundamentally changes what's possible for home labs, developers, and small businesses. You have literally created a completely secure, automated sandbox that sits safely behind a massive global edge network, and you did it without paying a dime for cloud compute. So the only question left to ask is, what are you going to build and self-host next?